Here we have one of our kinematic equations. In this video we're going to take this equation and solve for one of the variables other than the final velocity. Today we're going to be talking about how to get the initial velocity by itself, or how to solve this equation for the initial velocity. As I always do, I like to circle the variable I want to solve for as well as the entire term. In this case, the VI squared is the only term. Terms are things that are multiplied or divided. These are separated by an addition. To do this, to get this whole double circle by itself, we need to get rid of all this other stuff over here. Since it's being added to the term, to get rid of it, we have to subtract the whole thing. 2a delta x. And even though I didn't leave myself much room, on the other side of the equation, we have to do the same thing. Whatever we do to one side of the equation, we have to do to the other. So over here underneath, I'm going to say minus 2 times acceleration delta x. Alright. Now, on the right side, we have a positive 2a delta x minus 2a delta x. Anything minus itself is 0, so this whole right side cancels out, and all we're left with is the VI squared. However, on the left side, we have the VF squared still, minus all this stuff down here, minus 2a delta x. And as I said, on the right side, we still have this stuff here. Equals VI squared. Okay. Now, I said we want to solve this equation for VI, not VI squared. The last thing we have to do is get rid of that squared. Essentially, the opposite function of a square is a square root. Whatever we do to one side, we have to do to the other. The square root of a square then becomes just the variable in the center. So on the right side, we're going to have the VI. That's all that's left over. On the left side, we have the square root of all this stuff on the inside. The square root of everything. VF squared minus 2 times a times delta x. And there we have it. The equation which we start out with is now solved for the initial velocity.